All right, boys and girls, welcome to day 8. Today we're discussing things with 4 sides. Okay, the first thing is going to be parallelograms. Now, I don't want to spend too much time on explaining things. I want to work on problem solving, but very briefly, a parallelogram is something that has 4 sides. The opposite sides are equal to each other and parallel to each other. Now, one thing we need to be careful here is because these lines are parallel to each other, so we might, some cases, use this angle thing that we learned in the past. So if there's 2 lines parallel to each other and there's a line crossing them, then these 2 angles are equal to each other. So we might use that rule here and there. What do we have? Opposite sides are concurrent. Okay, we said that. The angles are concurrent. We said that as well. Consecutive angles are supplementary. A, B, C. So these opposite angles, they should add up to 180 degrees. And the internal angles of the four-side piece, geometric shape, always adds up to 360. The same way, let's say triangle was adding up to 180. Okay, diagonals bisect each other, meaning they divide themselves into 2 equal parts from the intersection points. And the rhombus is a very special case of parallelogram where all sides are equal, and whenever the diagonals are cutting each other, they create equal pieces as well, but they cut into 90-degree angle. Okay, so it's a special case of parallelogram where all sides are equal. All right, so with that in mind, let's solve some problems. In PQRS above, PT is equal to x plus 20y, etc., etc., etc. And what is the value of x? Now, you might say why there is so much information and we're looking for x. Now, this question has some other pieces down there, but we'll get to that. It has, I think, 4 or 5 parts. So, let's forget about angles for now because x seems to be representing the length. Okay, so let's ignore the angle stuff. What is PT? PT, let me make this marker a bit thicker. There you go. A PT is half of PR. Yes? Why? Because it's a diagonal divided by 2. And how do we know it's divided by 2? Based on the rule we just learned. Whenever they're intersecting, they create equal pieces. Okay? And PT says it's equal to x plus 2y. Okay, fair enough. ST, again, what's ST? ST is actually, I could write also, PT is also equal to TR. They're half pieces. And this is TQ equal to ST. And that's equal to QS. I'm not sure if we're going to need it or not, but just so we know, 8x minus y. Now, PR is 32. Okay, that's good. Which means this is going to be equal to 32 divided by 2, 16. Okay, seems like we might end up doing simultaneous equation, and we have one of them. And the second one, and then it says TQ is 26. So TQ is 26. ST also is equal to TQ, so that's also going to be 26. There you go. We have now simultaneous equation. So x plus 2y equal to 16. 8x minus y equal to 26. We can do substitution, right? We can say x is equal to 16 minus 2y, and then this will become, actually that became a bit ugly. Maybe we can do, how about we multiply this by, let's keep the first one. You will still get to the same answer, doesn't matter, but x plus 2y equal to 16. I'm going to multiply the second equation by 2. 16x minus 2y equal to 26. This is a y, by the way. All right, and if I add these 2 equations, I will get 17x equal to, I didn't multiply 26, did I? 52. This is going to be 68, and then x is going to be equal to 4. Okay, so what's the value of x? X is equal to 4. What is the value of y? It's still the same equation, so we know that x is equal to 4. what is the value of y? We can just substitute them in one of these. So we knew that x plus 2y is equal to 16. So we can plug it in here. 4 plus 2y equals to 16. Then 2y is going to be equal to 12. And y is going to be equal to 6. So the answer is 6. So far we know x and y. What's the measure of PQR? PQR, where is PQR? PQR is 1 and 2. So we're looking for angle 1 plus angle 2. Okay, we don't know anything else, but we also have some information about what angle 1, 2, and 3 are equal to. So remember that parallel line conversation we had. So angle 3 is supposed to be equal to angle 1 based on the parallel lines and a line that's cutting them. What can we do here? Angle 3 is equal to a squared minus 7, and angle 1 is equal to 6a. So what can we do? A squared minus 6a minus 7 equal to 0. That means a minus 7, let's do a plus 1, a minus 7. So negative 1 doesn't work out. So we can conclude that a is equal to 7. Okay, if a is equal to 7, that makes my angle 1, 6 times 7, 42. That makes my angle 2, 70, because of 7 times 10. And my angle 3 is going to be 7 squared minus 7, which is going to be what? 7 squared is 49. 49 minus 7, 42. PQR is 1 and 2. So angle 1 plus angle 2 is going to be equal to 42 plus 70, which is 112. Let me move it up a little so you can see. There you go. 112. And what is the measure of QRS? QRS is this angle. QRS is that angle. Now, what do we know about that angle? If we look at the triangle SQ and R, we know that internal angles should add up to 180. We have 2 and 3, and we're missing that R angle, which is what we're looking for. So 2, what's 2? 70 plus 42 plus this angle that we're looking for. Let's call it R. Should be equal to 180 degrees. So this is 112 plus angle R equal to 180. And then angle R is going to be equal to 180 minus 112, which I want to say 68. Let me write it here so you can see. Angle R equal to 68 degrees. All right, moving on. Rectangles, squares, and trapezoids. Now, rectangles and squares are pretty easy, so I will not get into that. We know what perimeter, what area is for them. Trapezoid is a bit complicated one, but again, it's not too bad. So what do we need to know in a trapezoid? Usually is the mid-segment, right? Because we need that to find area and stuff. How do we find mid-segment? We add bases and we divide them by 2. Very simple. We can have a trapezoid which sides are equal, which is isosceles trapezoid right here. And when they're equal, the angles are equal as well at the top and at the bottom. We have area of, what is this? Area of a rectangle is a product, okay, we know that. We know area of square, and this is the area of trapezoid. So let's solve some problems. In square ABCD, above, the length of a diagonal AC is 5 square root of 2. What is the area of a square? We started off with nice and easy. Now, let's call them A, and this is also A. Then we're looking at triangle ADC, which is a right angle triangle, which means Pythagorean theorem could be applied, which also means AC square should be equal to AD square plus CD square. Yes, we know what AC is already, 5 square root of 2 square plus or equal a square plus a square, just for simplicity, 2a square. And if we square this one, this is going to be what? This is going to be 50, I think. 50 is equal to 2a square. Then a square is going to be equal to 25, and a is going to be equal to 5. So we just found the side is 5. Are we done? No, because the question says what is the area of the square? Now area of the square is equal to a square, which is 25. There you go. Moving on. What is the area of trapezoid PQRS? Now, what do we know about the area of trapezoid? We know that A is equal to 1 over 2 height times mid-segment. So B1 plus B2. Base 1, base 2, and that's why we have 1 over 2 here, because we need half of it for the mid-segment, which is this part right here. But let's see what we have so far. We have some sides, we have some angle here, which seems to be, might be useful. The only thing we're missing from the area formula is height. Okay, so I'm going to drop the height here. And the reason I'm dropping that here is because this creates a nice triangle. Let's call this one, I don't know, B. Okay, now we have triangle PQ, or rather PBQ, which is a right angle triangle. Okay, and what type of triangle is it? It's 30, 60, and 90 triangle. What do we know about that? So, quick reminder, by the way. If this is 30, if this is x, then the hypotenuse is 2x. The other side is x times square root of 3. So, from these three sides, we only know the hypotenuse, which is PQ, which is 8. So, if that's 8, the side opposite of 30 degrees has to be half of that. So, 2x is 8, which means x is going to be 4. The other side is going to be 4 square root of 3. Not that we need it, but it's 4. So the height is equal to 4. Good, easy. Now we can calculate the area. 1 over 2 times 4 times 10 plus 3. And 1 over 2 times 4 times 13. This can go away. That's going to be 26. Area of a trapezoid PQRS. Now, to find the area of trapezoid, again, this is rotated, so you can think of this one as base 1. So this is base 1. Let me put it this way. Base 1, base 2. We can add them and find the mid-segment and then multiply by height. But we're missing two very important information. So area is equal to 1 over 2 times height, B1 plus B2. So what are we missing? We're missing height, and we're missing B2. So let's see if we can find that. Now, height is kind of given to us with this dashed line. Okay. Now, what do I have here? I have two right-angled triangles. Hopefully you can see that. So I've got Q, P, R, and I've got PRS. Correct? Now from PQRS, or what is it, QPR, I can find my PR. How can I find it? With Pythagorean theorem. So 15 square is supposed to be equal to 9 square plus PR square. Okay, do a little algebra here. So 225 minus 81 PR square. This is P. Then PR is going to be equal to 144, I think, which means that's a PR square. PR is going to be equal to 12. Cool? So PR is 12, which means we just found the height. Good. So one of them is check. And now we're missing B2. Now B2 can be found using this triangle. Now we have a right angle triangle with sides of 13, 12, and missing side, B2. So again, let's call it B2. B2 square is equal to 13 square minus 12 square. I'm not going to explain in detail, it's just Pythagorean theorem. 169 minus 144 that's going to be equal to 25, which makes our B2 to be 5. So we have two triangles, and we know everything about them. So we can now finally find the area. So area is going to be equal to 1 over 2 times height is 12. B1 is 9 plus 5. So 12 divided by 2 is 6 times 14. And I don't know, what's 6 times 14? 6 times 14, 4, 8. 84. All right, the last thing we're going to look at is some polygons and some angles about them. So what do we have here? The sum of measures of internal angles is n-sided polygon is n minus 2 times 180. Now you can actually see that from triangle. Triangle has 3 sides, so the equation is 3 minus 2 times 180, which is equal to 180. You can see that for square, 4 minus 2, 180, that's 360, etc., etc. So you don't have to memorize this, but just know that it makes sense. The measure of interior angles is this formula. Again, you can try it for triangle. If you put 3 for n, you'll have 180 divided by 3 minus 2 is 1. 180 divided by 3 is 60. The measure of interior angle of a regular n-sided polygon is this. What is 60? Wait. N-sided polygon. The measure of each interior angle of a regular n-sided. Okay, yes. Assuming they're equilateral. So for square, that's going to be 90, etc. The sum of measures of exterior angles of any polygon is 360. That's actually a very important information, but are you gonna need that on your SAT? Maybe, maybe not. The area of regular polygon is half the product of apothem A and the perimeter P. Okay, we'll get to that. So, regular polygons inscribed in circles, this is very important stuff. What do we need to know here? We need to know, actually some of this will be discussed in circles, but when you have equilateral triangle, everything is divided by 3, so 360 divided by 3, which is 120. Each angle is 60. So as the sides increase, you keep dividing it by them. So 360 divided by 4, divided by 5, etc., etc. Okay? So, now we haven't done circles yet, or did we? I don't think so. We haven't done circles, so that's all we need to know for now. All right, the figure above is an equilateral inscribed in a circle. Equilateral is the key word here. Inscribed in a circle with radius 10. What is the measure of AOC? Now AOC, we just learned, is just 360 divided by 3. Why 3? Because it's equilateral triangle. So it's going to be 120 degrees. What's the length of OD? Now what is OD? OD is a height of, if I isolate this triangle, so I've got AOC. OD is this, the height of this triangle. We know this is 10, we know this is 10. We know this angle is 120, which means each of them will be 60. Okay, if that's 60, this is 90 because it's a height. This is going to be 30. So from 30, 60, 90 triangle, we know that the side in front of 30 is half of the hypotenuse. So this is going to be 5. It's the same circle. More questions. What is the length of BD? BD, if you look at the image, BD is a combination of BO plus OD. Now you might say, why do I do that? Because we know what BO is. It's a radius, which is 10. And we know what OD is, we just found it. So the answer is going to be 15. What is the area of triangle ABC? Area of triangle is equal to base, which is AC, times height, which is BD, divided by 2. So what's AC? We don't know what AC is actually. We might need to find that separately. But we know what BD is. We know what BD is. AC, how can we find AC? Actually, we do know what AC is, sort of. So earlier we found OD. So this is 10, this is 5, this is 30 degrees. If this is x, this is 2x. This is going to be x squared root of 3, which is 5 square root of 3. Again, 30, 60, 90 triangle. So that's half of that. So AC is 2 times that. So the 5 square root of 3 is DC or AD. But AC is 2 times that. So 10 square root of 3 times BD is 15 divided by 2. And that's going to be equal to 75 square root of 3. So D. All right, that's all for this session. The topic was polygons and quads. I think we're day 8 right now. There will be another topic, maybe a day or two, about geometry as well, talking about circles and surface areas of 3D shapes. Make sure you check them out. If you have any questions or you would like to see something covered in this channel before the SAT exam, please do let me know. But until then, take care and I will see you tomorrow.